A very good evening, everyone. It is my great pleasure to welcome you all to today's online workshop organized under IoTrix 2.0. IoTrix 2.0 is an initiative that aims to promote innovation through Internet of Things technologies, introduce emerging technologies to the university community, and strengthen the connection between academia and industry. Today's workshop is designed to provide participants with a fundamental understanding of the Internet of Things and its growing impact on our daily lives and various industries. Throughout this session, you will explore the basic concepts of IoT, its applications, emerging trends, and the exciting opportunities it offers for innovation and future careers. We hope this workshop will inspire you to further explore this rapidly evolving field and become a part of the next generation of innovators. We are delighted to have you with this evening, and we sincerely thank you for taking the time to join this session. So before we begin today's session, I would like to share an exciting update with all of you. Alongside this workshop series, IoTrix 2.0 is also organizing an exciting competition that will provide participants with an opportunity to showcase their creativity, technical skills, and innovative ideas. We will be sharing more details about the competition, including the registration process and important guidelines towards the end of today's session. Therefore, I kindly invite everyone to stay with us until the end and not miss this exciting opportunity. So, without further delay, let us begin today's workshop. It is now my pleasure to introduce our speaker for today's session, Shehan Hettiarachchi. Mr. Shehan Hettiarachchi is currently working as a research executive in IoT and embedded systems at Sri Lanka Telecom plc. He has hands-on experience on Internet of Things, embedded systems, artificial intelligence, and telecommunications. His expertise includes solution design, prototyping, system integration, and research and development projects. We are truly honored to have him with us today, and we are excited to learn from his knowledge and his experience. So, ladies and gentlemen, please join me in welcoming Mr. Shehan Hettiarachchi. Sir, the virtual floor is now yours.
Thank you, Vasudhi. Am I audible?
Yes, sir, you're audible.
Yeah, okay. So thank you for the great introduction. So today I think I have like over 80 participants, right? So let me share my screen also. Can you see my screen now?
Yes, sir, your screen is clear.
Okay. So this is the introduction session, right? So I think we should start from the very basic things and the very beginner level things in the first. So first of all, let me ask you something. Are all these students from engineering faculty, or what is your degree program? I'm just asking, like, I need to like get some idea about like what is my audience. So you guys can, I think you can.
Yes, sir. Most of them are engineering students, undergraduates.
Okay. So I think everyone can use the chat, right? Okay. Oh, I see. There are some computer engineering students also.
We can use the chat box as well, sir.
Okay, so one question for the whole audience. I just want to know, like, if you have any prior experience with IoT projects, or do you have any module regarding IoT? Can you guys like just put the message just before we start this session? I need to like get this thing. Small experience. It is better if everyone can like just put a message in the chat. Okay, I think most of them are like very new to IoT, right? Okay, some have some experience also. Okay, okay, that's fine. That's fine. So I think this is a great audience for me. Like, if we can start from the beginning, that is wonderful. Huh? Okay, so shall we begin?
Yes, sir. Sure, we'll begin.
Okay, so this is the roadmap for the today's session. So we are going to cover all these areas. First, we will discuss what is IoT and what are the fundamentals of the IoT. Then we will discuss about MCU versus NPU. Don't worry, we will discuss everything from the very beginner level. So everyone will be covered now. Sorry, so no need to like, don't worry about anything. So the next part are GPIO, ADC, and basic peripherals. Also the communication protocols, sensors, and all the IoT architecture, and also edge computing. So these are all the basic and fundamental topics in IoT field. So we are going to cover basically all of these things. Okay, let's begin then. So first of all, first thing is, what is IoT? So when everyone is talking about IoT, and, most of them like if we ask this question, what is IoT? Most of the time, the answer will be a bit tricky, right? The definition of the IoT word is Internet of Things. Everyone knows that. But when we go deeper, what IoT means? Basically, with the internet, most of the devices that we are used to access internet, they are most of the time early days, all of them are mostly computers, right? Just desktop computers or laptop, basically computers. But with the time, there are so many new devices, so many new platforms, gadgets that are invented, that they also begin to connect to this internet network, right? So with that, there's a broader definition to this. So here you can see in the slide, IoT means connecting physical devices to the internet, but these devices are special. They can sense, process, and communicate. Also, they can act. They can take actions. So these type of devices, we can broadly say they are IoT devices, right? So for the examples, there are some examples given in this slide. So we all know GPS trackers, health monitors, those smart meters, those things we know, right? So most of everyone has one IoT device in our hands right now. Your mobile phone is also, according to this definition, it is also falls into this category, right? So in the modern world, there will be so like almost everything, all your household electronic components, all the let's say daily, all the let's say fridge, TV, from fridge to TV to washing machine, printer, whatnot, everything are nowadays connected to the internet. So broadly, we can say all these devices are IoT devices. But here, as engineering students, you are going one step below. So there you will have to design and you have to create these IoT devices, right? So that's another step below. So you have to go one step down. So now I think you have some idea what IoT devices are, right? Basically, any device that is connected to internet and also should be able to do some kind of action like this. Like it may be able to sense something, it should be able to process, and it should be able to communicate, right? Communicate means like it may be between two devices, it may be between cloud storage and with the device itself. It can be anything, or maybe with another human or something. It can be anything, but uh, broadly we can say IoT devices are the physical devices that are connected to the internet and can sense, process, communicate, and act. So that's clear, right? That is a very simple definition. So it's a very broad definition. I think it is clear for you. Okay. I'll move to the next slide. Okay. Now, why IoT matters? As we as we discussed before, in the modern world, everything is connected. So with these IoT devices, there are so many new capabilities and new doors are unlocked for us. Basically, remote monitoring, automation, data-driven decision making. Okay, let's go one by one. What is remote monitoring means? You can use the chat, guys. No? Okay, let's say remote monitoring. Uh, let's 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 say this kind of example. Let's say you have a garden with a tomato plants or something. So you want to monitor these plants, right? Like if they have enough water, enough nutrition and everything. So what happens with the time when you are busy with the work? Maybe you will like look after those plants like about 2 weeks. Then what happened? You forget the thing. And we all know what happened now. So if you can make like if you can install a IoT device or something, then you can remotely monitor, right? While you are working, you can monitor your plants. Likewise, you can do remote monitoring, not just plants, like nuclear reactors and all the military stuff. There are also the industry. Let's say there are some chemical, the machines that are working with chemicals and everything. So most of the time, humans can't like it. Humans can go, but it is very risky. So most of the time, factories are they are pushing to install sensors and IoT devices in these hard to reach areas. So uh, risky areas. So that's remote monitoring. So the remote monitoring is enabled by IoT devices, right? Then automation. Have you heard about the dark factories? I think most of you have, right? Can I get a raise of hands? Those who have heard about dark factories in China. No one? Okay, let's get a hand of raise like if you haven't heard this thing. Interesting. Ah, okay. Okay, so I'll explain. Dark factories are basically uh, the normal factories, how is the situation inside? Like there are so many workers there and so many, like, let's imagine apparel industry. There are hundreds of workers in the factories. They are well lit, right? Like otherwise they can't work, no? So all the factories are well lit, but the dark factories, they don't have any light. No lights. Why? All the human workers are replaced by robots and automated machineries, right? So these machineries, they do not require any light to function, right? So most of the areas of these factories are totally dark. So that is maybe the dark side of these kind of things. So, okay, that is automation, data-driven decision making. What is that? Let's say if you have IoT devices, I have a great example for this one. Data-driven decision making. You guys are using Google Maps, right? All of us have used Google Maps now. So you know how they show real-time traffic in the Google Maps. They are collecting all the data from the existing users, existing vehicles in those areas, and they can make a decision like if there's a traffic jam, like likewise they can make decisions, right? Then using those data, we can also make decisions. Like we can also choose, okay, this area is there's high traffic now, so I will use another road to go to my destination, right? Likewise, with this IoT data, we can make decisions, right? That is only one example. So there are so many cases, like so many examples we can take. Let's say also the factories and everything. There are so many decisions that are dependent on these IoT devices. Another thing is cost reduction. So this one I can relate. We can install monitoring devices. Let's say if you want to monitor, uh, let's say your some assets or some, let's say batteries or something that are installed in remotely. So you don't have to visit those places and take measurement or anything. You can install some IoT device or into those machineries and uh, take the readings from your home, right? So you don't have to visit there, you don't have to travel there. So there will be so many cost reductions in these processes. Also the predictive maintenance. So predictive maintenance means all the factories, like if there are some heavy machineries, most of the times we have to monitor them very closely. Let's say there are those machineries, if they stop working, whole factory might be losing hundreds of millions of money due to that machine, right? So predictive maintenance. With predictive maintenance, we can predict that this machine is going to fail. We have to repair it or like do the necessary measurements right away, right? So then we can avoid those uh, like emergency maintenance. And another last one is improved safety and efficiency. Improve safety and efficiency. You know, most of the time, did you remember the COVID times? Like there are some devices that measures body temperature and if the person is wearing a mask or not. Likewise, we have that kind of devices, IoT devices that improve safety and efficiency of our current like day-to-day lives, right? So these are very fundamental things, basic things. We should not waste too much time on these slides. So the real world IoT applications. Have you experienced any of these? Have you experienced any of this? Vehicle tracking, maybe you have industry automation, agriculture monitoring, same stuff. So we should move into the next slides. So I think you get the idea, right? We don't need to talk into this now. Okay, let's talk about the basic IoT system flows. So this is how the basic flow of data happening inside the IoT system. So the first thing is sensor detect physical data. Let's say very simple, let's say a temperature monitoring IoT device. So this one, first thing is it will detect the outside temperature using its sensors, right? Then what it do? Controller reads the data. Controller read the data using that sensor, and it has to then process the data. We will talk about deeper on these things later. Then data is sent through network. That processed data will be transmitted through a network. Then it will go to a cloud storage, and it will go through some analyzing tools if they have installed anything. Then at the final stage, users can view the result using dashboard or some kind of maybe app. It could be anything. But this is the very basic flow of IoT system. First sensor detect the reading, then the controller reads it from the sensor, then it get processed, then it will send to a network. Network means it could be anything like 4G, Wi-Fi, whatever. Then finally it will go to a cloud stores and it will be visualized on a dashboard or app. So this is the basic flow. Okay, as we talked earlier, these are the building blocks of a IoT device. First, you need a sensor, then you need the microcontroller or a processor, then you need the communication module, and of course you need power supply. You need power to this device. It could be also a battery, yeah. Whatever the power source, you need some kind of power supply. Then firmware or software. Then these devices are like, or mostly these devices are held in some kind of enclosure. Then network connection should be there, right? These are the simple building blocks for the IoT device. Up to now, are there any questions or any unclear things? If anything, please use the chat tab, or you can just unmute and ask. So I think everything is clear. Like these are very basic things. So okay, now sensors and actuators. So up to now we just talked about sensors, right? Now there's another thing called actuators. Do you guys have any idea? Basically, sensors are input devices, right? And the actuators are basically output devices. So there are some example sensors and actuators are there. Can you guys recognize any of this? Please use the chat. What are the sensors in these images? What are the actuators in the images? I would like all of you to participate in the let's keep this as a discussion, no? Not just a lecture like this. So can anyone of you identify any of these sensors or actuators? No one? PIR, LDR, ultrasonic, yeah. What are the actuators in these images? So basically this is the ultrasonic sensor. So with this one you can measure distance using sound waves, ultrasonic waves. This one is the PIR. With this one you can detect human motions, right? This is the LDR. You can measure the light intensity of the environment. This is a DHT11 temperature and humidity sensor. You can measure the temperature and the humidity of the surrounding environment. This is a gas sensor. I'm not sure what the specific gas that it can detect. It could be anything like from carbon monoxide to and the alcohol sensor. Everything looks like the same. We have to look into the data sheet or the model to get the specific type. And the actuators, yeah, it's correct. Relays are there, servos are there. So this is a relay. This is the servo. These are stepper motors. And this is a buzzer. This is a LED. And this is a water valve, right? So using these things, you can sense things from the environment and you can do some actions uh, with these actuators, and you can do some action, right? So these are basically input and output devices. So you will interact with these sensors and modules when you are going to build some kind of IoT device, right? Okay. Mm, okay. Here, now we have come to the microcontroller units. So likewise, like earlier, can you guys like recognize any of these? Just use it laptop. So microcontroller unit. Okay. Arduino board is there, yes. Here you can see the Arduino board. This is like I know most of you would know, right? Arduino board is there. What is this one? This one is also very famous. Yes, ESP32. But what else? Yeah, this one is a STM board. Also there are some Arduino boards similar to this one, but this one is a STM board. Yes. This one is 80 tiny 85 board. This one is a 80 tiny board. This one is also microcontroller. This is ESP8266. We also call it as ESP1. So these different devices, they are for different use cases. So this one is like actually this wording is not 100% accurate. This is not a computer, but we can just say it works like a computer because it processes the data. So this is a very miniature level computer, right? So we can control these sensors and actuators using this kind of microcontroller, right? So another great characteristic of this device is it uses very low power. So the low power consumption is a pro point for this microcontroller units. So another one is very common in embedded and IoT devices, especially ESP. ESP chips are very common and the STM ones. So, okay, I think you got the idea, right? This is, remember these ones, huh? This is the ESP32. This is the Arduino Uno. This is STM8. ESP8266. ESP01. We call it ESP01. And 80 tiny chips. So, they have their own pros and cons. We'll talk about it later. So, okay, let's move on to the next one. This is the microprocessor unit, MPU. So this is more powerful compared to the microcontrollers, right? It runs operating systems. It can run a Linux operating system, most of them. And these are we use these for heavy to do heavy processing. Okay. Also, what are these boards? Don't wait for me to ask. Just use the chat. What are these? This one I know all of you know. No one know what this is. Okay, one is there. Others? Yes, this is Raspberry Pi. Uh, what are others? This one is Orange Pi. This one calls Latte Panda. This one is NVIDIA's Jetson Nano. So all these are NPUs with they are tweaked in a different way for different things. Like Raspberry Pi is for more general use, and Latte Panda is more focused on x86, like with the Windows and to run Windows OS. Raspberry Pi is like the budget version of the Raspberry Pi, and this is Orange Pi, sorry, Orange Pi, and this one is NVIDIA Jetson Nano. This one has GPU acceleration built in. So these are much more powerful, right? Let's go into details. Okay. So here you can see there's a this side the cost is low, also the performance is low. In this side, cost is high, also it has high performance. Let's see. First, check on this. See the CPU, the processing unit here. This is a 8-bit core. It has the clock speed is 16 megahertz, right? Also the memory, let's say storage for your reference. It is only 32 kilobytes, right? The RAM is only 2 kilobytes. So this is kind of low performance, right? But this is totally fine for a fine to like for the to actuate and to the read all the sensors. So this is totally fine for that kind of task. We are just putting some script file in these devices. So this one is totally fine for the use case that it is designed. So when we come to ESP32, it uses dual core architecture, right? So this one is only a single 8-bit single core. So when it comes to ESP32, we have two cores, and it is also 32-bit. So huge improvement. Yeah? Also, clock speed has it's like almost 10 times, yeah? Over 10 times, right? 160 or 240 megahertz. See, also the storage memory, it is now 4 MB, and the RAM is 520 kilobytes. There's a huge difference between these two, right? But the cost is also like cost is mostly the same for this kind of Arduino Uno. It will cost like close to 1,000 rupees. ESP also it is also this it's kind of same price. It might be bit expensive, like it's under 1,500. So there's a huge gap between these two. Also, another thing, ESP32 has Wi-Fi and Bluetooth inbuilt. So ESP32s are very popular among embedded designs, and you will find it in almost like many of the IoT devices. You will find ESP chips, right? Okay. When it comes to the Raspberry Pi, it's in whole another. It's another level. It's in its own category, right? You can see now it has 4 cores, quad core, and it is 64-bit. Clock speed of 2.4 gigahertz now, like miles ahead. Also, the storage is it has M.2. It can connect to M.2 slot. So it has micro SD storage. So basically, like nowadays, normal SD card, what is the size? 1632. It's a 16 GB. So there's a huge difference between these two. And the RAM, it has 8 GB, 4 GB, 16 GB. There are few versions of the Raspberry Pis, but the default one has 8 GB DDR4, LP DDR4 RAM, right? So this one, between these two, also there's a huge gap. But Raspberry Pi, it will cost you around 20,000 rupees. So it is 20 times expensive. Okay, I think you got the idea, right? Can I see a raise of hand, like if you got this? Or if you have any questions or any unclear things, just ask. Okay, I only see one raise of hand. Okay, okay. For others who didn't understand this thing, I have another slide. It is like this. You got the idea now? Is it clear? Can I see a raise of hand now? Okay, okay. So many people have understood it now. If you didn't get it, tell me, yeah. Okay, so there are some cons as well. Let's say if you have to like interact with some kind of sensor that has very strict timing, then it is almost these microcontrollers are preferred, like because they don't have to run OS, like they are not depending on any OS. So sometimes it is a plus point. Okay. Mm. Okay. Here you can say it is in like what it is good for. Arduinos are good for testing, rapid prototyping, and for beginner level education purposes, right? ESP32 also good for prototype builds and pilot projects. Or if you need cheap microcontroller with Wi-Fi and Bluetooth, then you have to go with ESP32. For a IoT device, we need the connection, right? Like we need some kind of connection. So this Wi-Fi and Bluetooth are built into this controller. So it is a plus point. Then when it comes to Raspberry Pi, good for image processing, local AI models. You can run local AI models, well, like minimal versions, and you can run heavy applications. Or if you need any OS to be there for your use case, if you need an OS, then you can use this Raspberry Pi. You can use this Raspberry Pi as your normal day-to-day computer as well, if you can bear the pain. Like it is not up to par with your laptops, but you interested, you can use. So this is the story about MCU versus NPUs. I think you have clear idea, right? So okay, let's move to the next one. Okay, what are the GPIO pins? The definition is general purpose input output. So here in these controllers previously, you can see there are some connectors, right? All around these chips, there are connectors. See, so using these connectors, we can connect sensors and actuators, right? So these pins are called GPIO pins. So okay, are you guys logged in using your laptops or mobile phones? So you can access your laptop right now because we have some activities to do. Okay, have you guys tried this simulator? This is a ESP and Arduino simulator. You can just search Wokey. Yeah, someone. Yeah, okay. Some has some experience with these things. That is good. So shall we just go to the Wokey and try some try what we can do with this GPIO page. Also, there's another link here. I'll show you what we can do with these things. So first, shall we go to this website? This is a simulator. Let me go also. Okay, this is the other website. Here you can see the GPIO pins of the ESP32. Also, this is the other one. So this is the Wokey simulator. So when you first go into this uh, website, you will get with their home page. So here you can see you can use Arduino, ESP, Raspberry, STM, and all the major popular MCUs and APUs here. So if you want to start from the scratch, you can just select the ESP32. And here there are start templates like empty templates. So you can choose the ESP32 and start simulating. So here I have pre-configured one. This is your ESP32 board. So I have connected just a single button there. So here you can see uh, one pin is connected to the ground GPIO pin. The other one is connected to GPIO pin 27. So here I have got right a small sketch for this button. So have you guys ever try to write this kind of sketches? Do you guys have any experience? Sure. Wait, I'll share the link. Also, I think I can share this exact. Yeah, let me share this one. You can see the link in the chat, right? You can open this exact project, I think. Please, can someone verify that you can access this one?
Yes, sir, we can access.
Nice. So here, you just run the simulation. You can see here, this one, this is called serial monitor. You can say one serial. So one means true. So here the logic is inverted, but just ignore that one. So here now, one means button is not pressed, but if you click on the button, it will change to 0, right? You let it go, it will go back to 1. So this is a very basic example of how we use GPIO pin. Here we have used 27 pin in this website. Let me share this one also. you go to this one, you can see all the GPIO pins in the ESP. Also, if you scroll it down, then you can see what are the pins that you can use safely. If you can see okay, then it is okay for the inputs and outputs, right? If it say like this kind of like don't use it, then probably we should not use it, right? So that is the this is the very easiest way to know. So you can just visit this site. Otherwise, you will be like checking everywhere like why this is not working. So this is the so can like everyone like have you tried this thing? Just let me know. Is it working for you? It's working, right? So the sketch here is also very simple. We have two major parts. One is setup, one is loop. So in the setup, we define where we want to initiate the serial monitor, and we are going to use the pin 27 as an input, right? So in the loop, we are going to just do a serial print. What we are going to print? We are going to print the reading of this pin, digital reading of this 27 pin. We are doing it every 500 milliseconds, like every half a second, we are going to print it. So just few lines, you can read this kind of sensor, right? So this is just a button, but you can connect all the other sensors. There are so many sensors available in the simulators. So you can try it later. Okay, so this is working for you now. Okay, let's see. Okay, next thing is digital and analog. So you know what digital signals and analog signals are, right? Like you have some idea. Basically, digital signals are they are either high or low, or let's say true or false. There can be only two stages, high or low. That is digital signals basically. And the analog signals are they have a range, right? They are not just on or off, they have a range. So that is the basic definition I can give for you, like for these digital and analog signals. So here I have another one. Okay, here let me share this message. So in this one, I have a potentiometer connected to this ESP32. What is the potentiometer? You know, like with those all the amplifiers and everything, radios and everything, there are some knobs to adjust the volume, right? So this one is also that kind of potentiometer. So here the code is almost similar with one exception. Here we use analog read. Earlier we used a digital read, right? Here we are using analog read. Same as before, we are printing it every half a second. So when we run it, okay, now it says 0. If you just turn the knob, see, you can see some numbers, right? So the minimum is 0, the maximum is 4095. So that is maximum is the range, it's between 4096 and 0, right? Is it working for you as well? I think it should be right, the earlier one of our work. Okay, so this is a, here we have connected an analog sensor to a ESP32, right? So we can read these analog sensors as well. So are we clear on that? Up to now, everything is clear, right? We hope everything is clear because we are running out of time now. Okay, so let's move to the next slide. Okay, then next thing is, what is ADC? So all these controllers and all these microprocessing and everything we are using, they are totally digital, right? But how are they reading these analog sensors then? That's where the analog to digital converter comes in. Now. So here ADC can read an analog voltage, then it will convert that voltage into a digital value. So that is what basically happened on that last exercise, right? So we can read some analog sensors, and also uh, we can we can read all those things, right? So what are the other analog sensors? Here in this slide you can see light sensors, gas sensors, battery voltage, especially battery voltage. That is not just on and off, no. Battery voltage, like all your phones and everything, you can see the battery percentage, right? So that is also analog value. It's range from 0 to 100, right? Also a potentiometer. That's what we just use. So if you just go to the if you just go to that website again, here you can see uh, what are your ADC pins, ADC capable pins. So the pin we used here was GPI27. It is also a ADC capable pin. So we can use it to read analog sensors, right? Okay. Okay. Let's go back to the slides. Okay, then we have come to the communication protocols. What are these communication protocols and why we need it? Up to now, everything is clear, right? I'm not talking about these communication protocols. I'm like the other everything else. Up to now, everything is clear. If you have any doubt or any unclear thing, like just ask me in the chat. Okay, communication protocols. Most of the basic sensors and actuators, we can just use one GPIO pin and we can read the reading, right? Either digital reading or the analog reading, right? But when it comes to some complicated sensors and actuators, it is not the case. We need much more, like we need to transfer more data, right? Uh, let's say if you connect an let's say display, if you connected to any display, then you have to transfer so many details, right? It is not just one like yes or no or a analog value. So you have to send those details to communicate with different types of sensors and actuators. You need different types of protocols. So then you will ask like why there are different kinds of protocols. Yes, we can just use one. The reason is requirements are different for the different sensors and different actuators. The requirement is different. Some sensors they require very high bandwidth, like cameras and displays. These these devices they need bandwidth. Some devices they need speed, higher speed. Uh, some sensors they need full duplex. some just need hard duplex. So like this, different sensors and different actuators, they require different types of protocols. Okay, let's move on to our first protocol. Okay, here you can see this is the first protocol you have to work with. Inter-integrated circuits. We call it I2C. So using this one, you have one uh, master device, and you can connect several slave devices to this communication system, right? So the special thing is this one is only using two wires. One is SDA, one is SCL. So these two are the only two wires that carrying data. You can see there are four wires, other two are for the power. Okay, so this is mostly used for this kind of OLED displays. There are some sensors as well. So we can simulate this one in WOPI also. I have set up earlier. Let me show you. Okay, here. Okay, I'll share this one as well. Here, I have connected this OLED display using I2C protocol. So to use I2C, you can't just connect these I2C connections to any GPIO. You have to connect these to, you can use them, but there are some specific uh, separate pins for the I2C interface. So if you go to that website again, you can see what are your I2C pins. Let's see. Here, if you can see, there are two I2C pins, GPIO 22 and GPIO 21. 22 is SCL, 21 is SDA. So according to that, we can wire up this. Here SDA, here SCL. DA goes to GPIO 21, CL goes to 22. So very easy. Other one is just VCC power and ground. So with only these four wires, you can use this display simulation. Here, okay. Here you can see there's a message. Hello, is there. You can also change the message in the code. Here you can, if you change these values, these two strings, you can display a different message here, right? Okay. I think all of you are trying these simulators, huh? Just play with them, like, because they are simulators, so there is no harm like trying things. So is it clear? I2C protocol. The sketch is bit bigger here, but don't worry about it. If you just put it into the ChatGPT or any LLM, you can get the description of what these are. Also, there are some comments. Comments are in the code, so you can read them and get some idea. Right? Okay, let's move on to the next one. The next protocol is SPI protocol. So this one is kind of similar to the I2C, but this one use more wires. The benefit is it is much faster than the I2C. The con is it will be bit complex and you have to use more wires. So it is same. We will move to the next one. Okay, the next one is you are protocol. So in this protocol, what you can do is, if you have used GPS modules and communication modules, they most probably use UART protocol. So one special thing about this UART protocol is, if you can see here, you see one will be acting as a transmitter and receiver. It is full duplex. It could be either of them. But when this one is transmitting, that wire is connected to the receiver of the other party, right? This one's receiver is connected to this one's transmitter. This one's transmitter is connected to this one's receiver, right? Also, one ground connection is there. So this is the special thing you have to remember about the UART connection, that the wire should be going to the different pins of these two microcontrollers or whatever the circuits are. Basically, this one is talking and this one is listening. This one is listening, this one is talking, right? That's how the wiring should be. Okay. Let's move to the next. Here you can see in this chart what are the cons and cons of these communication protocols. UART is simple. I2C is easy to chain multiple devices. SPI, it is complex as devices increases because you have to use more wires, right? When it comes to the speed, UART is the slowest. I2C is second. SPI is the fastest. Numbers of devices. This one, it is only 2 devices you can connect. Transmitter, one will be transmitter, one will be receiver. It could change on the go. So I2C up to 127. The thing about I2C is each module, they will get an unique address that is hard coded. Like it will be specific to that devices. So you can like address and access those devices using that address, right? Then SPI, you can connect many, but it will get complex real zone. Number of wires, you are okay. For a single-sided conversation, only one wire, like one from one's transmitter to the other's receiver. But if you want full duplex conversation, then you need 2 wires. But for the bare minimum, you only need 1 wire. Then it comes to I2C. You need 2 wires, SCL and SDA. SPI, you need at least 4 wires. Here it is mentioned duplex is it's full duplex, but you need 2 wires. Otherwise, it is capable of full duplex. I2C is half duplex. SPI is full duplex. Duplex means you can talk bidirectionally at the same time, right? Similar to single, we talked about this one earlier. Okay, let's move on. Basic sensors, we talked about this one before. So, like there are some new sensors. So this is the temperature. This is like keep in mind these are the sensors. If you are going to do some kind of project in the future, these are the basic sensors you will use, right? So this is the basic humidity and temperature sensor. This is the LDR. This is the ultrasonic. So the use cases are you can measure temperature and humidity. You can measure light. You can measure distance using sound waves. You can detect if human or some kind of living thing, like let's say animal, big animal is there. If this sensor can detect infrared rays, right? So most of the bodies they emit infrared rays. So this one can detect it. And here's a voltage sensor. Here's a current sensor. This one is a gas sensor. This is a GPS module. Here, if you can see, I'm not sure if you can see this or not. There's RX and TX pins. RX, TX, VCC, and ground. Only these 4 wires are there. Okay, let's move on. Okay. Most of the times you will have to read the data sheets when you are going to select module or sensor or actuator, whatever, then you will have to read the documentation or the data. Like look for is there are some controllers, they use logic voltage as 5 volt, but most of the controllers they use 3.3 volts. If your module is outputting a logic level of 5 volts to a 3.3 volt microcontroller, then the controller will be damaged, right? Permanently damaged. So you have to be careful. So then the next thing is what kind of communication protocol that sensor or the thing you are going to connect is using, what kind of interface that it is using. You have to identify that also. And then you have to figure out that this sensor is within the range of measurement that you want to take. Let's say if you want to measure up to a 50 meter or let's say 20 meter thing, then maybe you can try with the ultrasonic, but then maybe you will not get the accurate result. Let's say you want very accurate results, then you have to go with the TOF sensor or something like that with the LiDAR, right? So likewise, you have to think about before you going to purchase some sensors or any actuators in the future, right? So another thing is designate calibration. This will mostly happen when you go with the analog sensors. One good example is those weight scale sensors. They you have they will require a calibration process before you use it. So this will be very confusing, but you have to check all these things before you're going to purchase some sensors. Okay, here is a good example for that. There are some current sensors. So this one is 50 amps, this one is 20 amps, this one is 100 amps. Which one are you going to buy? Also, like check the pricing. 50 amps, it's 1750. 20 is 1550. This one is 1500. This one is much cheaper and it can measure up to 100 amps, right? Maybe we should get this one. That's where you have to go back to this slide. This measurement range thing. If you go to the website, let me show you that I took this screenshot from. Okay, here this 100 amp one. Let's see. In the final details, you will see it is the error rate and the ratio of the reading. So here it can detect from 0 to 100 now. So the accuracy will be much lower. Let's say if you are going to connect this to a household, then it will only like use maximum of 20 amperes. So then you should, if you connect this thing, its reading range is much higher, right? Then the details of your reading will be way off. Let's say this one gives an error of 5%, then your final reading will be much off, right? Like it will be very different from the actual reading. So choose according to your need, right? Most probably this one will work best for you. So likewise, so that is one example. Okay, so time is running out, so let's quickly check this one as well. So the IoT architecture here, when you are doing some kind of IoT project, you need the device. You have the first thing is the device layer. There you have your sensors, your controllers, your actuators, and all the hardware stuff. They are in here. Then the network layer for the communication, like for you to transfer all the data, you need some kind of communication layer, right? It could be Wi-Fi, 4G, LoRa Ethernet, or Bluetooth. It could be anything, right? According to your need or according to your project, it could be different. Then the cloud layer. Here, there are some beginner friendly. I have mentioned some beginner friendly cloud platforms for you to try out. Blink, Arduino, IoT Cloud, things. They all have free tiers. Please check them out. Try to. They have especially Blink. They have great what they call tutorials there. Very easy to set up. Try this one. No? Then the application layer. It could be a dashboard, mobile app or something. Also the analytic layer. This will like analyze all these data and make reports and predictions, and maybe it could be feed to an AI. All the further things will be in this analytic layer, right? Okay, let's move on to the next one. Edge computing. What is edge computing? Let's say you have a smart CCTV camera. Then this one is working as an IoT camera. Let's say it is passing, streaming a video feed every time, like all the time, for you to like. Then you will be using some kind of image processing part and detecting people. Okay. So what happens with all the time? Let's say you want to install 100 of these cameras. Then finally you will have to pay a huge amount of money for the network layer, right? Because there are 100 video feeds you have to manage. Also, the cloud fees will be also through the roof, right? So what you can do is you can, without pushing all the video feeds to that side, you can do those process within the camera. Let's say you can install an Raspberry Pi or some kind of MPU inside this camera. Then you can process if there are any people and everything in the device itself. If there is some kind of people or animal or whatever, then you can see only that message. Okay, someone is here, intruder is here. That message is that is the only thing you are going to pass. So in that way, you can save a lot of bandwidth, a lot of money, a lot of cloud processing power. So you can save so many, let's say, cost while using edge computing, right? So most of the drones are also using edge computing. Let's say they lost the connection or something. Then they can navigate their surroundings and anonymously. So they are also using edge computing. Okay, so the summary of the session. Okay, now you know how IoT devices are, all the sensors and everything connect to the MCUs and the MPUs, right? So, and you know what are the MCU and MPUs and what is their different, what are the things they are good though, they are bad. So also GPIO and how to choose the sensors and the basic IoT architecture, right? So one activity is there, so maybe we have enough time here. Okay, I have set up this one. I'm going to give you one link in the group. I want you to go to that link and try to update it. Wait. Okay, here, if you take this link, okay, if everyone try this at the same time, maybe it will not work. So who's want to try this thing? Can someone send me a message in the chat? Hurry up, the time is running up. Who want to try this one? Okay, I'll paste this to the chat. If you are interested, you can try. Okay, edge computing means, do you remember those Raspberry Pi and those MPUs? They are good at heavy processing, image processing, and those they install and you are going to monitor full video to you. But outside, then there will be some kind of let's say people or animal. The drawback is you have to send the full video all the time, right? Uploading this video all the time. So your network bandwidth and all your cloud processing charges and everything will be much higher, right? Did you get that? Like that kind of scenario. The device itself before sending anything to the cloud site, right? So all the image processing, all the video in the device itself, and the lighter message, like if there is people, yes or no, like that kind of very simple messages, then sent to the network. Then you are only sending a small message, right? Not the whole video all the time. Is it clear now? Okay. Okay, perfect. So, okay, I'm going to give you that link. Yeah, I have pasted it. There you can see at the end of that link, there's a equal mark and there's one text. Right now it is my name. What I want you to do is paste that to your web browser and change that name at the end of the URL. Only change the name to your name. 5 seconds. This will get updated and the value will be taken from the cloud and it is shown in this display. Name just before the data is taken, then your name will be on this display. So I want you to try that one. So we are using Blink IoT platform here. So the code is also, I will share this code with you. If you are going to try this, you will be need to create an account and get this access token for yourself. I will be removing this token right after this tutorial. So you should try this on your own. So did you guys change the tried it or not? I'm still getting the same. My name is only. Is it clear or how to do it? Or should I show you one? Do you need any demonstration? Okay, one name is there. So if you made this device with the real hardware also, you can do this, huh? So this is a very today we have like we have done very basic uh, introduction level session for the IoT. So I hope all of you got some kind of idea about how our IoT systems are working and what are the things that you can do. Okay then. Any questions or any unclear parts before we wind up this session? Just tell me if you have any problem or any unclear things. Are we clear? Everything is perfectly clear. Okay, then thank you guys for having me for today's for us. We are just a speaker for your today's session. So that's it from my end now. Okay, thank you guys.
Thank you very much, Mr. Aditya Shehan Hettiarachchi, for that insightful and inspiring session. Your presentation has given us a better understanding of current technologies and their practical applications. So we truly appreciate the valuable knowledge and the experiences you have shared with us today. So, and I'm pretty sure that everyone here has gained useful insights that will help them in their academic and professional journeys. So, as we come to the end of today's workshop, I would like to express our sincere gratitude to Mr. Aditya Shehan Hettiarachchi for sharing his valuable knowledge, experiences, and insights with us. We would also like to thank all the participants for your active participation and enthusiasm throughout the session. We hope that today's workshop has inspired you to continue exploring emerging technologies and innovation through IoT. Before we conclude today's session, we are delighted to announce that team registration for the IoTrix 2.0 competition is officially opening tomorrow. We warmly invite all enthusiastic students and innovators to form their teams and take part in this exciting journey of innovation and problem solving. So the competition is a great opportunity to apply your knowledge, showcase your creativity, and to develop solutions that can make a real impact. Further details regarding the competition theme, rules, and registration process will be shared. And also, we encourage all of you to participate and make the most of this opportunity. We look forward to seeing your innovative ideas come to life through IoTrix 2.0. Stay connected with IoTrix 2.0 for more exciting workshops and opportunities in the future. So thank you everyone for joining with us. Have a pleasant evening and have a very good night.